Welcome to our channel, YourPedia. Today we have with us Professor S.S. Mantha. He is a great academician and an administrator. He is the CEO of Mahapreet Startup Knowledge Center, Mumbai, and also working as a professor at National Institute of Advanced Studies, Bangalore. He has been the former chairman of All India Council for Technical Education, that is AICTE. He has various awards to his name, and he is the author of various books and technical articles. Now let us have an interaction with him. So sir, you have been the chairman of AICTE. Can you share any two achievements as a chairman of AICTE?
There have been many that I can talk about, but in the main, when I joined the All India Council for Technical Education, there were a lot of problems in the interface. The public interface was questioned. There was corruption and so on. So therefore, what I did was completely automated the entire process, created new processes, procedures, and also set up the complete e-governance model where an application made to set up an institution or for any other service could be done sitting at home, and in the entire deficiencies chart was made available on their portal, and the final approval letter was also issued online. So that's one which created a lot of accountability and transparency in the system. People accepted it, and it's I'm happy that it's still running. That application that we created is still running, and the institutions are happily using it. So that's one of the things that I can mention. We had created a lot of assets for the organization. When I joined, we were in a rented accommodation at Janpath, and we built the new building that you are seeing for AICTE today. It's a complete green building. And we also created assets in Thiruvananthapuram as an AICTE regional office. We created an office at Bhopal, created offices at Assam, Vadodara, and so on. So all these initiatives have facilitated the people, the stakeholders, and the kind of acceptance that has come about subsequent to the initiatives that we have taken is extremely gratifying. The third I would want to mention is when I joined, All India Council for Technical Education had just about 43 crores as corpus with lot of liabilities. So because of the e-governance that we introduced and the payment gateways that we created for whatever payment, I mean there was no payment subsequent to that date which was done in a traditional cash kind of transaction. Everything was online, and I'm happy to say that after 6 years when I left AICTE, the corpus was 960 crore rupees. So we could do many, we could introduce new schemes, we could introduce scholarships for girls, for differently abled children. We could introduce many new programs and so on. So all in all, it has been a great journey for me to reflect back.
Okay, sir. So I think you got an award for e-governance initiative also.
Yeah, that effort at that time was appreciated by almost everybody. Turning an organization which was essentially human transaction based, and subject to a lot of activities that are not really accepted in a sane world. We moved on to a complete e-governance mode. So I think people had taken to it very well, and there were also requests for many other organizations for replicating those efforts.
Okay.
And back in Maharashtra, I had a background in IT, and we had introduced several IT projects for the government of Maharashtra, including the converting the higher education department to go paperless, and we also built the citizen facilitation center for the municipal corporation, which was later replicated in many other municipal corporations across the state. So the effort of IT, I mean involving IT and creating e-governance initiatives for the purpose of bringing in transparency and accountability into a system is extremely important, whichever is the department.
Yes. So according to you, what is the future of engineering?
Engineering is an applied science. I mean, we all understand there are basic sciences and applied sciences. So engineering, without it, probably the development that you see in any area, be it infrastructure, be it manufacturing, be it defense, be it space research, whichever area you talk about, or maybe plain comfort in our lives, everything needs engineering, and you need to apply the basic science principles in order to build build whatever that's useful in terms of making your life easier and so on. So engineering will be there as long as this this world exists. But having said that, there's a lot of changes that have been happening over a period of time, and especially in the last 2 decades. There has been a lot of change in terms of how we manufacture, how we look at engineering as a discipline, the new areas in which it has got into, and so on. So whereas in the earlier days we could clearly identify some basic disciplines like civil, mechanical, electrical, which are actually the building blocks on which the engineering edifice stands. Today it's more multidisciplinary, it's interdisciplinary. So therefore all the disciplines that come under, all the branches, specializations that come under engineering, they all have to talk to each other in order to create something meaningful. You look at any device today, for example, your washing machine, your laptop, your anything, your car that you drive, anything that you talk about is highly interdisciplinary, multidisciplinary, and so on. So therefore, saying that I will be a very good mechanical engineer or I'll be a very good electrical engineer, that's extremely important. One has to be very good in the discipline in which one specializes. But having said that, you also need to be extremely informed about the connecting links of a certain discipline with the other disciplines, and that is how engineering is progressing today. So therefore everything that people will do in future will not be just one single discipline but a mix of multiple disciplines. So that's a big difference that has happened. And the advent of computers and the computing technology, that has made a very big difference in engineering as a discipline. And For example, today we talk about artificial intelligence in almost every discipline, whether it's mechanical, electrical, whatever. And one other very important development that has happened within the artificial intelligence space is the natural language processing, the way we speak, to understand that, the way we write, to understand that. We all have a context in which we speak. So understanding that context based language and processing that, and then creating intelligent responses, patterns and so on, that has got into almost every single discipline, and therefore the changes to engineering have been, I should say, really profound over a period of time. So therefore that is something that the current generation will have to really look at and adopt and adapt.
So, but you said everything is multidisciplinary.
Yeah.
But these days, everybody is going in for computer science, engineering, and so what do you think about all this?
No, see, like I said, there is a basic discipline in which one has to be very good at. I mean, if I am in the performing arts, I must be very good at singing, or maybe I should be able to play an instrument very well, or maybe I should be a good orator. Things like that. Some niche value must be there for everybody. Now, that is not sufficient in order to make a meaningful living in today's world. That is where the multidisciplinarity comes. On this, you build other skills, and then you become extremely good. So therefore, computer science as a discipline has grown in the last 2.5 decades with multiple dimensions to it. Getting into different disciplines and so on. So therefore, application based discipline learning is becoming important. So therefore, if I am a student of mechanical engineering or maybe civil engineering, I need to understand not just civil engineering but the applications which come within that domain. And in making those applications, you need to build in the tools that are available today, and that is where computer science and things like that come in. Since somehow computer science is acting as a glue for all other disciplines, the employment potential is extremely high. So therefore, and it's also a discipline that's growing in multiple directions. Like I gave you one example of natural language processing. Today people talk about ChatGPT and things like that. So it's a natural language processing model. Now that you can apply to a washing machine, that you can apply to your car, that you can apply to maybe anything that you talk about in any discipline. So whether it's mechanical or electrical or civil or instrumentation or biomedical, whichever you talk about, there is an element of computer science built around it. So therefore, people, since there are more opportunities, because there are so many application areas where I can use the computer science principles, the algorithms and so on, the potential for computer science as an employment agency becomes extremely high. So that's one reason why students are veering towards computer science. One of the other areas is machine learning. And for example, if I want to teach a device, for example, you must be knowing there are devices which can understand what you speak and then go and open the refrigerator door and then pick up what you need, then close the door, things like that. That is one real-time application. So there is mechanical engineering, there is electrical, there is every engineering built into it, and there is a large component of computer science which integrates all these things into something that's meaningful. Yeah, computer science has today to bind the application areas and therefore it provides many more opportunities for employment. Even within the machine learning space, there is a huge opportunity in predictive analysis. So the idea is very simple. I mean, if I take 10 years data of weather in a particular location, and if I can predict that this year rains will be, you know, the precipitation will be very high or very low, or the farmers have to take you know, decisions based on all that is possible to be done today with machine learning algorithms. And of course there's a lot of information that is required. There is a IoT as a branch of you know, again I wouldn't say it's a complete branch of computer science, but it's a mix again of many technologies. You have transducers, you have all kinds of things in that. So therefore, whichever application you see today, it's more of course there is a mechanical engineering to it, there is an electrical engineering to it, and so on. Even if you look at manufacturing as a industry today, you have CNCs, you have DNC networks, you have you know, you can fire a program on a CNC sitting anywhere in the world because the internet and World Wide Web and so on. So, and therefore it's not just limited to mechanical engineering, you know, a machine tool. So there is a lot of you know, linkages to the computer science field and several possibilities that exist. So since we have applications in almost every single discipline, but integrating all of them, computer science provides many more opportunities for employment. So that's probably one of the reasons why students prefer today. But I must say computer science is only, I mean, the algorithms that you have, the methods that you have, the possibilities which you have through artificial intelligence or any other you know, any other process defined within computer science, it only has that much value if you remove the mechanical element, the electrical engineering element, the civil engineering element, so on. So they all have to come together to make something meaningful. So students must be good at acquiring skills which cut across the disciplines, not just concentrate only on computer science and writing some algorithm, or that may not be sufficient in future.
Yes. So, but these days industries are continuously complaining that the engineering students are not employable. So where are the fault lines?
See, the industry has been changing over a period of time. In the earlier days also, we used to hear the same thing.
Yes,
there were people who join industries, they don't have the skills and so on. Today, the industry is still saying the same thing. It's nothing new. What we must understand is the industry is varied, and you have all kinds of things being manufactured, and therefore the variance within the industries is extremely large, extremely huge. You have pharmaceutical based industries, you have purely manufacturing industries, you have space technology, you have you know, electronics engineering technologies. Even within, if you look at just the mechanical engineering industry, you have thermodynamics, you have fluid mechanics, you have hydraulics, you have, so the industry space is extremely varied. That is on the demand side. Look at the supply side. You have universities, you have disciplines, specific disciplines. In the early days, you had only civil, electrical and mechanical. They were the building blocks. Chemical engineering came out of mechanical. Your metallurgy came out of mechanical. Your electronics came out of electrical engineering, and computer science coming out of electrical, and so on. Communications coming out of electrical, and things like that. So in a 4-year undergraduate program, probably you cannot build every skill that is required by every industry. It's just not going to work out. So therefore, there is a certain element of training that is required within the industry for a certain job role. Now, industries are not willing to do that because they want a ready-made product which will start working, right from day one. So that is just not workable. So, having said that, somebody has to do that training part. We have today industries which are also outsourcing the entire training part to different agencies. Anyway, that will evolve over a period of time as the opportunity rise and as the need rises and so on. But what we need to understand is that a university system in its 4 years of 3 years or 4 years of learning, it can only do so much. It cannot do everything. A university per se is there to provide deductive learning. You do logical analysis, you do basically rationalize, you understand, you think, and you apply logic and things like that. That is what the university does. It teaches you certain basics, certain concepts, and builds the logical skills, the analytical skills, and so on. So with those skills, you try and apply your basic understanding in an industry where you join eventually, and you learn on the job and so on. So deductive learning is what should happen in the university. Now, experiential learning is something that happens on the job. So therefore, one cannot say that experiential part also must be a university responsibility. It cannot be. But today, because of the pressures that we have, because of the employment markets that we have and so on, we really need to connect somewhere the teaching learning part to the employment opportunities that we have. But yes, I'll be very worried if the basic logical skills are not there, the basic mathematical skills are not there, the cognitive skills are not there in a child when he goes to for an employment. Then of course there is something seriously wrong. But the domain skills, yes, I mean they can be learned. They can be learned over a period of time. The basics, concepts, that must be very clear in any domain that the student is in. If there is a deficit of domain skills, if there is a deficit of cognitive skills, then there is something seriously wrong. But an industry coming back and saying they don't have any skills is not acceptable. The point is, you cannot build every skill that is required by the industry within the university. So both of them have to start re-looking at what the expectations are. What is the expectation of a child, of a parent from the university? What is the expectation of the industry from a student? And try and bridge the gap through additional learning, such as micro credentials, such as fractional credits. Build those skills that are required by the industry outside the university space, or if you want to make it part of the university space, something can be worked out, but not everything. So therefore, it's very necessary for both of them to understand the reality, and then the children are good. Believe me, if you go to any university, of course there are all those kinds of classifications. There are good students, there are not so good, but they can be good, and there are students who are just not bothered, and this percentage may vary in different universities. So we have students who are good, who are willing, who are passionate to learn, who have the skills, but they need a little direction, and that is what the university must do in the current system. And one other thing which the university must do in today, especially in today's times, is build values. How it does, there are ways of doing it. Most of the value system comes from the family, from the peers, from the friend, and so on. But then if there is a way of channelizing those skills within the university system, because that's a very impressionable age,
Yes.
when the child is in a college, university, and so on, if that can be done, nothing like it.
Sir, what do you think that the students, engineering students, should go in for post graduation, like like M.Tech and MS?
I mean, today you have a very high level of skills required. See, fundamentally what has happened is the employment market was a pyramid-like structure earlier, as we understand, which means that the low skills but large numbers at the base of the pyramid. As you go up, you need higher order skills, but the number becomes lesser, you know. But today what has happened is because of artificial intelligence, intelligent agents, most of the entry level jobs are automated. At a time, we know, we used to hear at one time, companies like Infosys, Wipro, TCS, they were all doing literally body shopping.
Yes.
They were picking up good students, sending them abroad for coding, writing, code. Now that doesn't happen anymore, because that code is all generated, today. Even the pseudo code, the code that is required to run, everything is generated today through, there are applications which do that. There are rapid application development tools and so on. So the entry level jobs are all disrupted. There are no jobs like that. So what is happening now? You need higher order skills even at the entry level, and as you go up, you need even higher order skills. And these numbers that you require are also going down. So at the entry level, you need higher skills but less number of people, and as you go up, that so therefore the entire pyramid-like structure is changing to some pipe-like structure. Now, where do people get these higher order skills that we are talking about? So in a way, it is good to get into a postgraduate program. Build those, you get additionally 1 year, 1.5 years, and you also can also do some internship. With that as a background, you build on your undergraduate skills, and then you get into understanding the industry sector much better. Today, the industry is also transforming. It's changing to a lot of new technologies have come in, like the industry 4.0 skills, which I know in India we still are struggling with. There are many industries which are still not even into industry 2.0 and 3.0. They are now talking of industry 4.0. So there are at least 10 technologies that drive industry 4.0. They all need very high-end skills. Some of them can be built as a part of the curriculum, not everything again. So what cannot be built must come in as additional learning outside the classroom, and or maybe do a post-graduation, build those skills, and be more successful within the employment sector. So it's always good to do a postgraduate program, but from a good institute. We have, I don't know how many, more than 3,000 institutions which are into providing 3,700 odd institutions in undergraduate education, almost 2,000 of them giving you postgraduate education. So for postgraduate education, you need facilities, you need good faculty, you need good infrastructure, so that some real learning happens. Otherwise, what is the point in doing a post-graduation?
Yes, sir.
It's like that.
So what are the good domains for them to do M.Tech, MS or PhD?
What is it?
What are the good domains where the students can
there are several domains. I mean, if you look at the Indian industry, there's not much of research that happens. Most of the technology comes from outside, and they end up doing minor modifications and manufacturing to the quality standards set up by their partners. But there are several domains which are coming up. Health sector is one. Energy, green energy is another. Electric vehicle technology is another. In green, you have renewable energy sources. That's coming up very fast. You have hydrogen as a fuel. That sector has a huge opportunity. Artificial intelligence, machine learning, which can cut across all these areas that I mentioned, whether it's EV or whether it's green energy or smart grid, smart agriculture. Agriculture has huge opportunities. Yes. And again, AI and ML can make a very big difference in agriculture. So these are all the domains that will be extremely useful in time to come to make that. But then one has to be sufficiently trained in at least some of those areas which eventually they would want to be in,
Yes, sir. So should the students prefer India or abroad for this higher education?
I would say undergraduate education is as good as any available in the world in India. It's absolutely no issues there. Of course, like I said, this is a large system. We have a large number of colleges, so you need to invest a lot of money into providing the quality initiatives. Whether it's infrastructure, faculty, whatever, or the overall development of a child, and so on. So there are many. At least I would believe that 30% of the institutions have all the facilities that are required to a reasonable extent. There are another 20% of the institutions or universities which can make the grade, provided they have their bearings at the right place. If they want to invest money, and then they can go into the top, the first bracket. But there are at least 50% of the institutions or universities which need to do a lot of soul searching and provide facilities and invest in faculty and so on. It's not that education in India, education is the only activity that is devoid of recession. The whole world may get into recession, every sector may get into recession. Education will never get into recession in India, because everybody attaches a premium to that. Every parent wants their child to learn, study, and therefore they will invest, maybe even sell off all the family holdings, but they still do that. So we need at least 50% of the institutions to make the grade. Then I would say they're not good. For 30% are fine, about 10% are very good, 20% are maybe good, the next 20% are satisfactory, and the remaining 50% are poor. So undergraduate education in India, in this, it's easy to say this, but then what happens is, like water finds its own level. You can't have quality, end-to-end quality, okay? You will have good quality, you have acceptable quality, and you will have poor quality. In anything that you talk about.
Yes.
You buy toothpaste, even there you can do all this classification. So education is not different. And the student population also is like that. The faculty population is also like that. So the good teachers will get into IITs, the next ones will get into NITs, the next one will get into good universities, and so on. So the poor faculty will get into the poor institution. Similarly, the poor students will get into the poor institutions. It's not my saying, but that's the way the world is. It's not a function of India. It's across the world. You can't have in the acting in a cliched statement, you can't have a Shah Rukh Khan across. Every actor can't be Shah Rukh Khan, or every actor can't be an Amitabh Bachchan. So you will have other people also, and there is a clientele for every single. That is how multiple markets come up. So having said that, for undergraduate studies, yes, it's good. But I believe in India, except maybe 10% of the institutions or maybe 20% of the institutions, rest of them will have to invest much more into their postgraduate education, into creating the research facilities and so on. So therefore, that's where the problem is. And most of the children who go out to study, they do it for 2-3 reasons. One of them is much better research facilities, much better connect with the industry. We don't have that here. For example, in a US university, the professor who probably is your guide for MS or PhD will be much better connected with the industry. He'll get industry related problems, and that's where the student adds value by working on them. And the general facilities, the research facilities that are available within the institute are much better than what they are here. So that's the second reason to go there. The third reason, of course, is very one can't probably do anything about it. The opportunities to make a better living in their eyes, whatever that better living means, and the quality of living is much better, and the possibility of making more money. So that's the reason people prefer to go out. My personal belief is, if you are really wanting to do something good in research, be recognized for your research, for your industry connect, and for your ability to solve problems and so on. Then for postgraduate education, probably it's US.
Yes, sir.
And then maybe a few universities in the UK and Germany.
Germany, because
but Germany, you need to learn German. Of course, you need to learn the local language anyway, wherever you go. If you go from Karnataka to let's say Punjab and want to do something in Punjab, you better learn Punjabi. It's as simple as that. So the same applies in other countries as well. But the scope, the opportunity to be with the best, to connect with the best of the industry, to connect with best of the research facilities. If you want to do all that, then that's the way to go.
Yes. Sir, while considering post-graduation, should they consider the domain or the course in which they want to do, or should they consider college where they get admission?
No, both are important. I mean, once you get into post-graduation, your options are much more limited than at the undergraduate level. So therefore, college does make a difference. If you look at the ranking agencies, whether it's the Times Higher Education Foundation or the QS rankings or ARWU and so on, these three are the most sought after. There are many more, there are 20 more. If you look at them, they all attach a lot of importance to the research that happens within the university, within the institution. They attach a lot of importance to the faculty that they have, what kind of research the faculty. In fact, ARWU also speaks about how many Nobel laureates are there in your faculty, and how many Nobel laureate alumni are there who have graduated from your universities. So they attach that kind of importance to faculty, to facilities, to research, and so on. So therefore, it's of course important to be in a good institution. But if you are extremely concerned about what specialization you're doing and so on, then obviously that comes apart, but that comes as a point to consider. But if both of them combine, then nothing like it. Both are important.
So how much scope for youngsters do you foresee in practical implementation of Industry 4.0 in our region?
Industry 4.0 has several technologies. There is nothing like Industry 4.0 per se. In the early days, we had what is that? Manual. Most of the things were manual, and a few automated devices were there, and so on. Subsequently, we had semi-automats, automats, and things like that. Then we had machines which could be programmed, and like I said, CNC on a DNC network. You can program from anywhere, sitting anywhere in the country. First shift program, you change, you manufacture something. In the second shift, you manufacture something else. All that was possible. Now you have a scene where machines can talk to machines. A machine can determine whether it needs maintenance now, whether the preventive maintenance schedules are met, whether the the lube oil is going down, or everything it can determine on its own. It can talk to the other machine, it can talk to other devices, and so on. So all that happens because of a large amount of technology that has come into the manufacturing space. In the early days, we used to talk about profit. When you set up an industry, it's only profit. So eventually we moved into people welfare. So we also spoke about people now, and people welfare measures, and not only profits will increase, people are happy. So the second concept was of people. And now, of course, we are talking of sustainability. There are all those 17 sustainable development goals. So it's now, it's also the planet. So you have to protect the planet in as much as using its resources to produce and all that, So Industry 4.0 cuts across all these technologies. Yes, so it's not just automation, it's a lot of, there are at least 10 technologies that define Industry 4.0, and it cuts across every single element of the supply chain. Yes, those technologies could be your AI, machine learning, your blockchain, your your IoT, and your communications, every single, your 5G, your development ops, all that is a part of Industry 4.0. So again, not all of that can certainly be taught in a classroom, but then the building blocks to learn all of them must certainly be a part of the university system. So if some of it cannot be learned within the university system, then like I said before, micro credentials, fractional credits, all that must be obtained, maybe by subscribing. There are various organizations, various third-party content providers. You can always subscribe to them, get these certifications done, and so on. So Industry 4.0 is a real thing today. People are now talking of Industry 5.0 as well, where the planet part comes in. So technologies will evolve, and the university system must not do all the time a catch-up. Probably it should be one step ahead by understanding what the industry needs are. So that is where the value, you can build the value proposition for a student.
So you talked about hydrogen-based vehicles. So what future do you see in that? And can India be the leader in that?
No, anybody can be a leader in that. There are a lot of research will be, see, the problem with it's very high, you know, pressures that are required to store hydrogen in liquefied form. That is where its utility comes in, and very low temperatures. So you will, unless you create a very good mechanism by which you can store hydrogen safely and release hydrogen safely, until that happens, use of hydrogen can be a problem. So a lot of research keeps happening in terms of storage of hydrogen and release of hydrogen to do some useful work. There are already vehicles running on hydrogen. There are, you know, the entire buses running on hydrogen, and the technology is there, but there are safety aspects. Okay. So unless these are addressed, essentially the storage part and the release part, if they are addressed, then you know, hydrogen doesn't exist as a the minute you release it, it combines with oxygen, and you know, so therefore and there can be explosions there at those pressures and so on. So therefore safety is a very important aspect. The day, I mean, we have technology to address all those issues. People are they are into that research. Therefore, it will be there one day, like electric vehicles. A few years back, people thought we didn't have technology to, you know, for those batteries. You know, today you get a mobile battery that retains charge for, you know, for number of hours. Yeah. So, but you also hear, you know, batteries exploding. So it's like that. Unless you build very safe measures, use of technology can be a problem. But there is research across the world which is addressing these issues, and we should see much more use. In fact, in Bangalore, you have 1 out of every 4 vehicles is an electric vehicle today. So the usage will be, so maybe 5 years from now, you will find many more hydrogen fuel cell driven vehicles.
So how can we imbibe a spirit of entrepreneurship in our students?
See, there are entrepreneurship. Fundamentally, what happens is we are all family driven entrepreneurs. Whether if it is a you know, even our surnames are built around the profession that we do. So many of those skills that are built, they come from the family. You know, the grandfather teaches the father, father teaches the son, son teaches his son or his daughter, and like that. If you see most of the jewelry design, it's completely family business. Yes. You look at your you know, I think Moradabad, you have those brass mirrors, you know. Yes, so these are all extremely skilled jobs, but they come from generation to generation, and there are several such textiles, embroidery, you know, you name it is there. Having said that, and entrepreneurship can also probably be taught in a scientific manner, and the ecosystem can be created for one to become an entrepreneur, and then you can connect them to the money, you know, venture capitalists, and then it's all up to the individual. It's all up to those people, how innovative they are, and how. That is where probably you need a little bit of entrepreneurship in the genes. So not everybody can become an entrepreneur, but yes, I mean, personally, I thought family driven entrepreneurship is about 60%, and our institution driven, education driven entrepreneurship may be about 25%, maybe 20%. That's all.
So we have around 23 IITs now, and we talk about IITs and the IIT driven systems and all that. Would IIT be able to make desirable impact on plight of a nation?
In spite of?
In plight of a nation. Would they make a desirable impact?
In the growth of the nation?
Yeah, the difficult situations and the growth of the nation.
No, IITs have been set up, they are our best institutions. They have over a period of time given a lot of, good students who have contributed to the development of the nation. They will continue to do so. That's because they have started as niche institutions, were funded by the government, and the best people came together, the faculty, the students, and so on. And because of the funds they get, they created good research facilities. They have had good collaboration. There are institutions which are set up by, initial IITs were set up by France, by Germany, by US, and so on. So later on, the local expertise, the local skill sets have all improved the systems, and IITs will continue to do their bit in building the economy. There are in Indian bureaucracy, if you see, I believe at least 20% of the Indian bureaucracy must be from the IITs. So they have also contributed in administration, and they have also contributed in general growth in economy, like everyone else. They have also contributed.
Yes, sir, lastly, I want to ask you, what are your views about your ideal engineering college?
There is nothing like an ideal engineering college. You need to build something on best practices, and you need to, the inputs must be quite calibrated and acceptable in the current institute industry interface that happens. So for that to happen, you need first of all good ambience. As a university ambience must be there. Then good faculty must be there. Teaching, learning methodologies must be properly defined, established. There must be a free, free enterprise. People must be free to think. A university is a place where group of people come together, they air their views. They may be at loggerheads, that's fine. That is the purpose of the university. There can be different views, there can be different ideas, and so on. So the university must be able to allow all this to happen, and out of that things which will support the society, support the government, support the ecosystems, that will come out of this process. So that if something like that happens in a university, it must have good connect with the industry, it must have connect with the society. The best of the people must come and interact with the with this, whether it's students or faculty or whatever. So if all this, then of course a student must have an all-round development. There must be sports facilities, there must be literary opportunities available, which leads to overall growth of the child, like that. So if all that happens on a university, that's maybe the best thing. There's nothing like ideal. A university, there are no limits to its growth. The leader makes a difference. If the leader is good, the university can rise. The systems can rise. People will prosper and so on. But if the leader is questioned, then you have a problem.
Yes, sir.
A good institute or a good university also can collapse.
Yes. Thank you, sir. Thank you for sharing your views with us. Thank you so much, sir.
Thank you. My pleasure.